Okay, so here's homework number 24, 1 through 8, and 11 through 12. Angle of elevation, depression. Okay, so for this problem, make a right triangle, right? Now, when it says Brian's kite is flying above a field at the end of a 65 meter of string, so that is going to be your guys' hypotenuse. An angle of elevation to the kite measures 70 degrees. So you guys know that the angle of elevation is the angle formed from the line of sight to the ground, which is this one right there. So it asks how high is the kite above Brian's head. So then basically we know that the height of the kite is this one right there. And there's good old Brian with the kite. Alright, so you guys just solve for this. So we got sine of 70 is equal to x over 65 over 1, cross multiply, and we get x is going to equal 65 sine 70. Put that into your guys' calculator, and you guys are going to get 61. Oops. But you guys are supposed to get 61 point. Ooh, this is kind of lagging. 61.1 degrees. Oh, not degrees. Meters. That's how high the kite is above Brian's head. All right. Number 2, from an airplane at an altitude of 1,200 meters. So here's my gross airplane. There's my triangle. And right, when I take a look at this, 1,200 meters in the altitude, which means 1,200 meters off the ground. Next, the angle of depression to a building on the ground measures 28 degrees. So if I make this line, you guys, this angle right there is 28 degrees. That's the angle of depression. Now recall, right, angle of depression is the same thing as angle of elevation. They are congruent. Oops, angle of depression. Angle of depression is congruent to angle of elevation, and this one is the angle of elevation. So this is 28 degrees. All right, and it says find the distance from the plane to the building. Well, the building's right here, so that means you're solving for that. So, in the perspective of this angle, of that, we got opposite and hypotenuse. So, we're going to get sine of 28 is equal to 1,200 all over x. Put that over 1, cross multiply, and we're going to get x sine 28 all over 1,200. Divide both sides by sine 28. So x is going to roughly be 1,200 divided by sine of 28. 2,556.1 meters. 2,556.1 meters. And there's that one. Number 3, from a point on the ground 12 feet from the base of a flagpole. So here is the base of the flagpole, and here's the point. So from the point to the base of the flagpole is 12 feet. Okay, the angle of elevation of the top of the pole measures 53 degrees. So from here to there, angle of elevation, they said, was 53 degrees. How tall is the flagpole? So this is from the perspective of the angle, right? From the perspective of 53 degrees, we got opposite and we got adjacent. So that means we're going to be using cosine. So cosine of 53 is equal to opposite over adjacent. Put that over 1. Cross multiply. X is going to equal 12 cosine x. Oh, nope. Cosine of 53. 12 cosine of 53. Put that into your calculator and you should get that 7.2. It's going to be 7.2 feet tall. Okay. Number 4. So I showed you guys this number 4, but let's show you guys again. Okay, from a plane flying due east at 265 meters above the sea level. So let's first make our first triangle. So a plane is flying due east, right? Which is to the right. So it is going in this direction, due east. So it says it's 265 meters above sea level. Okay, so it says the angles of depression of two ships sailing due east measures 35 degrees and 25 degrees. So we know that it has two angle of depressions, which also means it has two angle of elevation. So this first angle of elevation is going to be 35. Remember, angle of depression and angle of elevation are the same. So that's going to be 35. Now it says we got another one, 25. So I'm going to make this and make this angle. So this one is going to be 25 degrees. And this is where the first ship is, right there. And this is where the second ship is, right there. So it says how far apart are the ships. So that means you guys are solving for this x. Well, we basically have two triangles, right? We have this smaller one. I'm going to highlight it so you guys can see. Oh, that's not a highlighter, Mr. Taguchi. This is a oh, and that's way too thick. Okay, so we got that triangle, right? And we got this one right here. If I could make it. All right, so we got that bluer one and we got the red one. So first, let's try to find the red one. Now, let's just solve for this side length. Y. So tan of 35 is going to equal opposite over adjacent. So 265 over y. Okay? And then that's going to really be y is equal to 265 tan 35. Okay, so that's to find that first y length. Now, in order to get the other one, so this whole length, we'll just call that z. So remember, that whole triangle has a degree of 25 degrees, right? So tan of 25 is equal to opposite over adjacent. So we're going to have 265 all over z. Cross multiply, so z is going to equal 265 tan 25. Remember, we're trying to find the two ships' distance from each other, right? Which is x. So for the red one, it says it's roughly going to be 265 tan of 35. That gives you guys 185.6 meters. And for the purple one, for z, we're going to get 265 tan of 25. which is 100, 10, 35, and this one's going to be 123.51. A two ship sailing due east 35 degrees and 45 degrees. Yeah, that looks a... Oh. Okay, so you guys, I messed up on this part. Now, do you guys see how I cross-multiplied? I cross-multiplied incorrectly. So this is going to be y tan of 35 is equal to 265, and then divide both sides by tan 35. So y is roughly, there we go, not bad. So 265 divided by tan 35 is going to be 378.5. 378.5 meters. And for the purple, we're going to get z tan of 25 is equal to 265. All divided by tan 25, and you guys are going to get z is roughly 265 divided by tan 25 for 568.3 meters. And then to find our x value, we do z minus y in order for that equal to x. 568.3 minus 378.5 equals x. And we're going to get 100. X is going to be roughly around 189.8 meters. That's how far apart the ships are from each other. 189.8 meters. That's probably one of the more challenging ones, you guys, so don't worry if you don't understand it at the moment, but that's a good problem, okay? One of the more challenging ones. Okay, number 5. I'm just gonna do a right triangle since, you know, all of these have right triangles. Okay, a man flies a kite and lets out 100 feet of string. So here's 100 feet of string. Here's the kite, and here's the man. The angle of elevation of the string is 52 degrees. So here's the 52 degrees, because angle of elevation, right? The line of sight to the ground. Now, how high off the ground is the kite? So you guys are trying to figure out that one. And then it says how far away is the man from the spot directly under the kite, which is this value. So we actually have to find x and y. Well, let's do red. So in order to find x, this is going to be opposite and hypotenuse. So sine of 52 is equal to opposite over hypotenuse. Put that over 1, cross multiply. X is roughly going to be 100 times sine of 52, which is x is roughly around, drum roll please, 78.8. Okay, 78.8 feet. Nice. Now let's do the y. Okay, this is adjacent, and here's a hypotenuse, so cosine of 52 is going to equal adjacent over hypotenuse. That's over 1, so y is going to roughly be 100 cosine of 52, so y is roughly going to be 61.6 feet. So the kite is 78.8 feet off the ground, and from the man to the kite, if you were to stand directly underneath the kite, be 61.6 feet away around. Alright? Number 6. Okay, from the top of the cliff, which is 40 meters high. So let's draw a triangle. Okay, there's a cliff, right? There's a cliff, 40 meters high. Angle of depression, right? So here's the angle of depression, which is, the angle of depression of the island was 34 degrees, but you know that's also the same as the angle of elevation. How far is the object from the base of the cliff? How far is the object from the base of the cliff? From top of the cliff, the angle of an object that is, how far is the object from the base of the cliff? So here's the object right there. So then how far is the object from the base of the cliff? Okay, the base of the cliff is right, the top of a vertical cliff. Oh, of a vertical cliff. I don't think that helped with the drawing. But anyway, so the base of the cliff is right here. So that means you guys are solving for this value. So that means that we will be using, what is that? Tangent. Opposite and adjacent. So that means tan 34 is going to equal to 40 all over x. Cross multiply, so we're going to get x tan 34 is equal to 40. Divide both by tan 34. X is roughly going to be 40 divided by tan 34, which is 59.3 degrees. Oh, not degrees. 59.3 meters. Okay, so there's that one. Okay, number 7. An airplane takes off 200 yards in front of a 60-foot building. Takes off 200 yards in front of a 60-foot building. Okay, so draw. Okay, so here's 200 yards. The building is right there. And the airplane is taking off. So the building is 60 feet. And it's 250 yards in front of a 60-foot building. Okay, so this one we're dealing with yards and feet, right? And it says, at what angle must the plane take off in order to avoid the crashing of the building? Okay, so 60 feet and 200 yards. So we're dealing with two different measurements, so we should just stick with one. Well, there is... So what we have to do is, well, first it says at what angle must the plane, so we're trying to find the angle of elevation, which is this. That theta is the thing we're trying to find right there. So what we have to do is just make a conversion with our feet and our yards. So since we know that 3 feet are in 1 yard, let's just change this to be yards. So 60 feet times there's 3 feet in 1 yard. So 60 divided by 3, 20. So we know this is going to be 20 yards. So I just converted it to yards, and now let's find our angle. So in the perspective of that angle, we got opposite and we got adjacent. So we're going to be using tan of theta is equal to 60 over 200. So to find theta, we just do tan inverse to both sides of 60 over 200. And theta is going to be roughly around 16.7 degrees. 16.7 degrees. Okay, number 8. I'm gonna draw my right triangle. Okay, a 14-foot ladder. So here's the ladder. Okay, 14-foot ladder, that's 14 feet, is used to scale a 13-foot wall. Here's a 13-foot wall. At what angle of elevation must the ladder be situated in order to reach the top of the wall? So here's the angle of elevation, and now we just solve. So this is gonna be opposite and hypotenuse, so sine of theta is equal to 13 over 14. Do sine of inverse of both sides, so we're going to get theta is equal to sine inverse of 13 over 14, and sine inverse of 13 divided by 14 is 68.2 degrees, so roughly around 68.2 degrees. Okay, 11. Standing on a cliff 380 meters above sea level. So standing on a cliff, which is I'll draw that better. I don't know if you could say that. Okay, so 300 meters above sea level. Pat sees an approaching ship and measures its angle of depression, obtaining 9 degrees. So here's the angle of depression, which right here is 9 degrees, which is this means the angle of elevation is also 9 degrees. And here's our ship, right? How far from the shore is the ship? So that means we are trying to find this x value. Now Pat sights a second ship beyond the first. The angle of depression of the second ship is 5 degrees. How far apart are the ships? Okay, so this is very similar to the other one, but first let's find this one, okay? So we know that this x value, to solve for it, we just have to do in the perspective of this angle. So it's going to be opposite and adjacent, which means we're going to be using sine of 9. Oh no, tan of 9. Tan of 9 degrees is equal to 380 over x. Cross multiply, x tan 9 is equal to 380, divide both sides by tan 9. And we are going to get x is roughly, so 380 divided by tan of 9, 2,399.2 meters. Okay, so that's from the shore to that ship. Now, it says Pat sights a second ship beyond the first. The angle of depression of the second ship is 5 degrees. How far apart are the ships? So if we use the same drawing, right? I'm going to move everything over as well. So if we use that same drawing, but now this new degrees, right? It says he sees it at 5 degrees. This angle of depression would be 5. So then he sees a second ship that's further away from the one he saw from the 9 degrees. And we should see what the distance is from this ship to the shore. So basically we do, this is opposite we're still using opposite and adjacent. So tan of 5 is equal to 380 over x. Cross multiply, x tan 5 is equal to 380. Divide both sides by tan 5. And we're going to get x is roughly around, so 380 divided by tan of 5. 4,343.4 meters. Okay, so that's when he sees from an angle depression of 5 degrees. So what that means is that if we go back to this, he saw another ship all the way out here. And that was 5 degrees. So we just subtract the two lengths from each other. So 4,343.4, subtract that by 2,399.2, and we are going to get 1,944.2 meters. That's how far the two ships are from each other. Okay. So there is that one. Now, last one, number 12. In a right triangle. Oh, perfect. Right triangle. The hypotenuse is 58 centimeters, makes a 51 degree with one of the legs. Okay, so 51 degrees. To the nearest tenth of a centimeter, how long is that leg? Finding that. Nice, this is adjacent hypotenuse, so we're going to be using cosine. So cosine 51 is equal to x over 58. So x is going to equal 58 cosine of 51 degrees. So x is going to be, how long is our leg? We got 58 cosine of 51. 36.5 meters. Oh, centimeters. Right? So that's how you guys do your angle of elevation and depression. So hopefully you guys, this helps you with your homework assignment. And you guys try your best, okay?